Alright, so today we're going to talk about solving. I can solve polynomials in factored form. Okay, so I can solve polynomials in factored form. A polynomial is in factored form when it is written as a product of factors. So for example, you see standard form, which we talked about earlier, x squared plus 2x. Factored form is when I could take the GCF, right? And x squared and 2x, the GCF is x because that's what they both have in common. I take that out and I get x plus 2. So 7.6 is all about how to get from standard to factored form. In this lesson, everything will be given to you in factored form, but one day we're going to go from standard form to factored form and then solve for x. That's where I want you to be in eventually, and that's what we'll learn how to do in the upcoming lessons. When one side of an equation is a polynomial in factored form and the other side is 0, use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are called roots. Where there's that word, roots. Okay, so what is a zero product property? What is that? Well, that's just saying if the product of two real numbers is 0, then at least one of the numbers is 0. So for example, if I have like 5 times xy equals 0, well, x or y must be, one of those has to be 0, right? Because if I have like 5 times 5 times 0, you get 0, but then if you have like 5 times 1, that can't be 0. So that's what the zero product property is saying. It's saying at least one x or y has to be 0. If a and b are real numbers and a times b is 0, then a equals 0 or b must equal 0. So how can we apply this to algebra? So for example, I have x and x plus 8. So remember, whoops, I want to use a highlighter. It is a product, right? So I have x times x plus 8 equals 0. Those are my two products. So I set both of these products equal to 0. In this first one, I have x, right? You said just this one equal to 0, just this one equal to 0. You have x equals 0, so that's already solved for. That's a nice one. And then the second one is going to be x plus 8 equals 0 minus 8 minus 8. X equals negative 8. So that means you have two solutions. You have x equals 0 and negative 8. Okay, so you set both of these polynomials equal to 0 and you solve them separately. Okay, so for example, the next one we'll do is I have x plus 5 times x plus 6 times x minus 5 is equal to 0. I'll highlight these so you see I have two separate binomials here, and I set each of them equal to 0. So this first one is going to be x plus 6 equals 0. Second one is x minus 5 equal 0. Minus 6, I have x is equal to negative 6 plus 5. Plus 5, I have x equals 5. So my solutions are x equals negative 6 and 5. Okay, so that's all you have to do, really. So for why don't you guys try these next 4 on your own? Okay, be careful with this one, number 4. Rewrite this in expanded form, right? Expanded form is you have, if I have b plus 7 squared, that's saying b plus 7 equals 0, and then from here figure out what b is going to be equal to. For that one you'll only have one solution and you'll see why. Okay, all right, next one. What are the solutions of this? So this is essentially the same thing. So you see how I have 2, here's 1, here's 2 equals 0. You must see an equal 0. If you don't see an equal 0, you can't solve it. So if it just says like 3a plus 7, well, that's 3a plus 7. But then if it says 3a plus 7 equals 0, you're like, oh, now you can solve for a. If it doesn't have that equals 0, you cannot solve it. So in this one, I have 2a plus 7 equals 0. 2a minus 7 equals 0. Subtract 7, you have 2a equals negative 7. I have a is equal to negative 7 over 2 plus 7 plus 7. I have 2a is equal to positive 7 over 2. Oh, whoops, positive 7 divided by 2, you get a is equal to positive 7 over 2. I was getting ahead of myself. So a is equal to negative 7 over 2 and 7 over 2. You don't have to put the comma, you could put an and symbol, it really doesn't matter. I just like to do it that way. Okay? The next example is the following. So the arch of a fireplace can be modeled by y equals negative 1 over 9 times x plus 18 times x minus 18, where x and y are measured in inches. Find the width of the arch at floor level. So, as we said earlier, we're setting this equal to 0. Why? Even though it doesn't have a 0, you're figuring when it is at floor level. Here is the floor level, right? This is when y equals 0. So when it asks for what is the arch, so you're trying to figure out this point right here. I'll use a different color. You're trying to figure out this point right here and this point right here. This is when y is equal to 0. So that's why I set this equation all equal to 0. So 0 is equal to negative 1 over 9 times x plus 18 times x minus 18. Okay, so this one's a little tricky, right? Right now you're like, well, I see 1, I see 2, and I also see 3, right? You see the negative 1, 9 outside, and you're like, well, what do I do with that? That doesn't have a variable. So if it doesn't have a variable and it's just a number outside, you can completely ignore it. I'll use this color. You can completely ignore it. If it has an x outside, you have to solve for it as well. So if you have 0 is equal to x times x plus 2 times x plus 3, then you see how in this one I have an x outside, right? Then I have to set this equal to 0, this equal to 0, and that equal to 0. If it doesn't have an x outside, you ignore it. But if it does have an x outside, that is also a solution. Okay, so going back to this problem, I don't have an x outside, so I ignore it, right? So I'm going to have x plus 18 equal to 0, x minus 18 equals 0, minus 18, minus 18, x equals negative 18, plus, I have x is equal to positive 18, so x is going to be equal to negative 18 and positive 18 as my solutions. So what that means is this point is going to be negative 18 and positive 18, where the width of the arch is at floor level. Okay, so why don't you guys try the next 5, 6, and 7 on your own. Use the examples above to help you out. And if you have questions, feel free to ask me the next day. See you guys tomorrow.